Okay, this is your review for part 1 of the practice test 8. Question number 1. Find the first 3 terms given this expression. So what they're asking for you to find is a sub 1, a sub 2, and a sub 3, meaning that you're going to put in a 1 for n in all of the places where there are n's. In the first one, a sub 1, the first term will be negative 1 to the first power times 2 times 1 over 1 plus 3. And we know that negative 1 to the 1 power is negative 1, 2 times 1 is 2, and 1 plus 3 is 4. So you have a negative 1/2 after you reduce this fraction. Same thing for the next two. You're going to put a 2 in for n, and you'll get all of this, and you should be able to come up with a positive 1 times 4/5, which is 4/5. Now pause it right now and see if you can get the third one on your own. Okay, I hope you've tried that, and if you put a 3 in there, you should be able to end up with a negative 1. Number 2, find the first 3 terms. Now this is a recursive. That means you take 1 and you place it into the formula, and then you'll give you the next one. So the next one, well, we'll start with the first one. That's given. That's negative 2. And the next one will be 2 plus 3 times negative 2, which is 2 plus negative 6. That's negative 4. And the one after that, you're going to do it again. 2 plus 3 times negative 4. Go ahead and pause this and finish that one. Okay, you should have gotten negative 10. Okay. Next, number 3. For the following, find the sequence. For the following, for the sequences, find the 24th term and the sum of the first 24 terms. So first thing you have to determine is what kind of sequence do you have here. We have 4, 11, 18, and 25. Hopefully you are able to find that we're going to be adding 7 each time, right? 11 minus 4 is 7, 18 minus 11 is 7, 25 minus 18 is 7. So adding 7 each time, that makes arithmetic. And makes our common difference here is 7. So now we need a formula for the sum, or the explicit formula, right? The explicit formula for any term is a sub n is equal to the common difference times n plus the term before the first one, or c. At the very end of this video, on the last PowerPoint slide, I'm going to have all the formulas in one place so you can copy them down and get them all memorized. So let's see, I think we have everything we need. We're going to find the 24th term, and we're going to find the one before the first one. And the one before the first one should be 4 minus 7, the first term, minus my common difference, which is negative 3. Negative 3 would have been up here if we continue this pattern. So now the 24th term will be 7 times 24 minus 3, or 168 minus 3, which is 165. Now we're going to find the sum of all of the first 24 terms. Right? So we're going to use Gauss's formula, and we're going to take the sum of any number of terms is equal to how many terms we're adding together, divide by 2, times the first term plus the last term. So we know everything now. So let's find the 24th term is 24 over 2. First term is 4, and our 24th term is 165. Okay. We're at 12. 24 divided by 2 is 12 times 169. We get 2028 is the sum of my first 24 terms. Number 4. For the following for the sequences, find the 8th term, the sum of the first 8 terms, and find the sum of all of terms all the way to infinity, or the infinite sum. Okay, so we will first figure out what kind of sequence we have here, and seeing this, it's probably going to be a geometric, because we can never find the sum of an arithmetic, because we're adding something each time. It will just keep running away from us. Alright, so we're going to find to see if this is a geometric. So we're going to divide -6 by 12, we get -1/2, and then 3 divided by -6 is a -1/2, and then -3 over 2 divided by 3, which is -3 over 2 divided by 3. When we divide a fraction, we take the reciprocal of the 3 and multiply, and the 3's cancel and get -1/2. So we do have a common difference here of all the terms given. So we know it's geometric, and we know the common ratio. Did I say difference? I mean the common ratio is -1/2. So we have our formula for the geometric explicit formula, or any term in a geometric sequence, is going to be this formula here. We have the first term, we have n, which is 8, we have r, the common ratio. So we're ready to do this. So we have the 8th term is equal to the first one times my common ratio to the n minus 1, and -1/2 to the 7th power is -1 over 128, reducing that a bit, and we get the 8th term is -3 over 32. Okay, finding the sum of the first 8 terms. We have a formula for that, and that formula is this. For a finite sum, we have a different one for an infinite sum. This finite sum, let's see, do we have everything we need? We have the first term, we have the common ratio, and we have n. We do, so let's go ahead and do this. So we have first term is 12, common ratio is -1/2, and n is 8. Now cleaning this up here, I'm going to take -1/2 to the 8th power, and I get positive 1 over 256, and get 1 minus the -1/2, and getting a common denominator up here in this part of my fraction. I have common denominator is 256 over 256 minus 1 over 256 will give me 255 over 256, and 1 plus 1/2 is 3/2, and 12 divided by 3/2 is 8, and multiplying this, or just reducing this here, we get 32, and 255 over 32 is the sum. Now we're not trying to get this as a decimal, but I want to get this as approximate decimal to show you something in the next part. This is going to be about 7.969. Okay, just remember that for a second. Alright, and then the last part here, we're trying to find the infinite sum. And the infinite sum, knowing that r is equals to -1/2, is this formula. It's almost the same thing where just the numerator is 1. So if we do this formula, we have everything, and then we have to make sure when anytime we use this infinite sum formula that we have to check our r. The absolute value of r has to be less than 1. If you take the absolute value of r and you get something greater than 1, it cannot be done, because this thing is going to keep growing to the point where you're not going to be able to find the sum. So it has to decrease to a point where we can find it. So doing that, we have all our pieces here. We get 12 times 1 over 1 minus negative a half. 1 minus negative a half is 3 halves. And 12 divided by 3 halves is 8. And that's the infinite sum. Now remember in the last part I said, remember what happened to the sum of the 8 terms? It was approximately 7.969. Well, the more we add to this, the closer we're going to get to 8, because the pieces that we're going to add are going to get smaller and smaller and smaller. So eventually, if we get to infinity, we would get a number like this. Okay, and just going by the first 8 terms, we get pretty close. But if we continue, we would get 8. Number 5. Find 3 arithmetic means between 5 and 19. Okay, find 3 arithmetic means. So I want 3 numbers between 5 and 19, like this. And it's arithmetic. Arithmetic meaning that we're going to add the same number each time. Well, you can sit here and try and guess what it is, but I wrote this out so that you couldn't guess this very easily. It's not like 2 or 3 or something like that. So we're going to actually have to go through this as an exercise here. And we know arithmetic means that it's linear. And when things are linear, we can think of them as a slope. Okay, so a common difference is going to be some kind of slope each time, adding a slope to this each time. And how do we find the slope of this? Well, we know the first term is 5, and because there's 3 in between, that means the 5th term is 19. So we have this thing going on. We have the first term 1 comma 5, and the 5th term 5 comma 19. And we know how to find the slope of that, hopefully. You know, this is an Algebra 1 skill, right? Finding the slope, we're going to take 19 minus 5 over 5 minus 1, the y's over the x's, and we get 14 over 4, and that's 7 halves. We're going to add 7 halves each time to get these 3 terms, and that's why I said it's not going to be very likely that you would have been able to guess it was 7 halves. Okay, now knowing that each time we're adding the common difference, I'm going to use this recursive formula. So the second term is going to be the first one plus my common difference. So 5 plus 7 halves, and getting common denominator, this will be 10 halves plus 7 halves. That'll give me 17 halves. That's the second term. Now the third term will be 17 halves plus another 7 halves. So we have a common denominator. That will be 24 halves, which is 12. And then the fourth term, instead of using the 12, I'm going to use the 24 over 2 because that's my common denominator. Add another 7 over 2, and I get 31 over 2. Okay, so I have my 3 terms, and I always want to check. This is kind of not very intuitive, so I always want to check to see if I can actually get back to the 19. So get the 31 over 2, add another 7 over 2, I get 38 over 2, which is 19, and that checks. Okay, so that tells me that the 5th term is really 19, and the 7 over 2 is correct. Number 6. Find 2 geometric means between 16 and 54. Kind of the same thing, but this time it's geometric. We're going to want to find 2 things in between here to give me 54. This time it's geometric, and we cannot think of it as a slope because this is not a slope, it's a curve. Geometric is exponential. It's an exponential function that has a curve. So now I'm going to have to approach this a little differently. We're going to have to use a formula. So we have this formula. Any term in a geometric sequence is equal to this. So we have the first term, we have n, and we can actually find r, because if we know that this is going to be first, second, third, and the 4th term, when n is equal to 4, the 4th term is 54. So I can say that we need r here, so n is 4, and the 4th term is 54. So I can put 54 in here, is equal to 16, the first term, times r to the 4 minus 1, or n minus 1. So dividing both sides by 16, 4 minus 1 is 3. Reduce this up a little bit here. I get 27 over 8. Now taking the cube root to clean off this exponent, both sides, I know that 3 times 3 times 3 is 27, and 2 times 2 times 2 is 8. So that makes r 3 over 2. I'm going to use another recursive here. The next term is the last term times r. So 16 times 3 over 2 is reduce that and get 8 times 3 is 24. The next one, the third term, doing the same thing again. 24 times 3 over 2. Reduce this as 12 times 3 is 36. I have my two geometric means. I just want to double check if I can get back to my 54. So I'm going to take the 36 times 3 over 2, reduce that, I get 18 times 3, which is 54, and that checks. Number 7, the sum. Find the sum and show your work. This you have to already know just by looking at that is arithmetic. There is no exponent on here. So it's not going to be geometric. And it looks like a line. Y is equal to mx plus b. Negative 4 is going to be my slope, or the common difference. So if I know this is arithmetic, we're going to use the arithmetic formula for sum. Okay, and we know that from 1 to 80 we have 80 terms, and the first term and the last term is what I need to finish this. So I'm going to have to put in a 1 for k to find my first term. So the first term is equal to 12 minus 4 times 1, which is 8. Also have to find my 80th term, and the 80th term is going to be 12 minus 4 times 80, which is negative 308. Putting all this in my formula right here, I get the sum of the 80 terms is 80 over 2 times 8 minus 308. 8 minus 308 is negative 300. 80 divided by 2 is 40. 4 times negative 3 is 12. Add a bunch of zeros, add 3 zeros to it. I get the sum of the first 80 terms is negative 12,000. Number 8, find the sum. Show your work. Now, this is a little trickier. This is definitely not linear, but since the exponent is my k, then I know it's geometric. But now I have two bases. Normally, the base is my common ratio. So this is going to take a little bit, one little extra step here. We know this is going to be a finite geometric sum. Finite means it ends at some place. Okay, it doesn't go to infinity. So I'm going to find the first term, which means that k is 3. Okay, and this is for my finite geometric sum. We need the first term, which means that k is 3. We're going to put a 3 in here, and we get negative 1 to the third power is negative 1. 3 minus 2 is 1, and we get negative 1 times 1/2, which means the first term is negative 1/2. Now we need to find r. We don't know what r is. R would have been the base, but let's see here. We're going to put in our next term, 4. Okay, we know we can find r by dividing a4 divided by a3, so that's why I'm finding the next term. I'm going to put 4 where the n's are, or where the k's are, and we get negative 1 to the 4th power, which is positive 1. 4 minus 2 is 2, and then 1 times 1/2 squared is 1/4. Now if you find the common ratio is the 4th term divided by the 3rd term. 1/4 divided by negative 1/2 is negative 1/2, and we're good to go. Now we're going to use this formula, putting everything in here. The first term is negative 1/2. r is also negative 1/2. Take that to the 8th power first. I get 1 over 256. In a common denominator, 256 over 256 minus 1 is 255 over 256. And 1 plus 1/2 is 3/2. Negative 1/2 divided by 3/2. The 2's will cancel and I'm left with negative 1/3. And this comes out to negative 85 over 256 because the 3 will reduce here. Number 9, find the sum, show all work. Okay, this is very similar to the last one, but we have r here because that's the base of my exponent. So we know that r is going to be 3 over 2, and we know that this is an infinite geometric sum. So we're going to use this formula right here. S sub n is equal to the first term times 1 over 1 minus r. But whenever we use this formula, we always have to check to make sure that r is less than or equal to, less than 1. Can't be equal to 1. Less than 1. Well, it is not, because 3 over 2 is more than 1. So there is no infinite sum. If on the test this happens to be like 1/2 or 2 over 3 or something less than 1, then you'll just be putting the numbers in here and finishing it off just like the last problem. Okay, just be careful that you might get one where the r is too big, because in this formula the numbers keep growing to infinity. Number 10, determine the number of terms n in the series. So the first term is 19, the nth term is 96, and the sum is 690. And they tell you it's arithmetic, so you're going to use these formulas. Now I have everything I need here, so I'm going to go ahead and use this. I can't use this right now because I don't have the term before the first one, because I don't have d yet. So in fact, it looks like I have everything in here. I have s sub n, which is 690, and then I have the first term, and I have the nth term, and I can find n, so I don't even need this formula. I have everything I need right here. So I'm going to be putting 690 in here, solving for n over 2, times the first term plus the nth term. Adding those together, I get 115, and then just cleaning up just a little bit, I get 115 over 2 times n, which is the same thing as this right here. I want to get rid of the 115 over 2, so multiply both sides by 2 over 115, cancel the 115s, cancel the 2, do the same thing on this side, and this comes out to 12 when we multiply 2 by 690 divided by 115. Final answer. Number 11. This one seems to be a little tricky. Okay, so we want to find how many terms are in this series. And just looking at this, I can tell it's going to be geometric because I'm multiplying by a -4 each time. Or 16 over -4 is -4. And we know if I times 16 by another -4, I get -64. So that works for all three terms. So now we have a geometric. And geometric, are you going to use a geometric sum formula? And let's see, do we have everything? We have the first term, we have s sub n, the sum, we have r, we're solving for n, we're ready to go. Okay, putting the 52,428 is equal to the first term, 1 minus the r to the nth power, 1 minus the r again. Alright, and I'm going to divide both sides, or I'm just going to add the 1 and the negative. 1 minus the -4 is 5. And -4 over 5, I'm going to get rid of that in one step. Some of you may prefer to divide by -4 then multiply by 5, but I'm going to do it all together as 1. Divide by Negative 4 multiplied by 5, multiplied by 5 over 4. That'll cancel the negative 4 and 5. Do that on this side. I get a negative 65,535. Subtract 1 from both sides. I get negative 65,536 is equal to negative of a negative 4 to the n. Now you can't make this positive because order of operations says you do exponents before you can multiply by this negative 1. So I'm going to divide both sides by negative 1. I get this. And we have an exponent that's a variable. How do we solve this? Do you remember from Algebra 2? Yes, we take the natural log of both sides to bring the exponent down to out of the exponent position. So we take the natural log of 65,536 is equal to n times the natural log of negative 4. You're probably thinking, because you're so smart, you go, Mr. Ho, you can't take the natural log or any log of a negative number. And that is correct, you can't. But we don't know where this thing had a negative in it in the formula to make these numbers work. And especially if the first term is negative, that means there was a negative in there somewhere outside of the exponent. So we can actually just take the absolute value of this and see if that works. We're going to divide both sides by the natural log, the absolute value of negative 4, which makes it positive. And when we do that, we do find that it does work, and we get an 8. And you can try this, multiply by negative 4 8 times, and you should actually end up with this, which verifies that we did this correctly. Almost done. Number 12. Simplify. Okay, negative 1, n minus 1 factorial over n plus 1 factorial. Well, factorial just means we start with this number and we go all the way down to 2, or starting from 2 and going all the way to this number. So I'm going to write it all out. So I'm going to start with this and take away 1 each time. So n minus 1, take away 1 is n minus 2. Take away another 1 is n minus 3. Take another one away until we get all the way down to 4, 3, 2, 1. Do the same thing with n plus 1. n plus 1 minus 1 is n plus 0. n plus 0 minus 1 is n minus 1. n minus 1 minus another one is n minus 2. n minus 2 minus another one is n minus 3, all the way down to to 4, 3, 2. And we just cancel these, and we're left with this. Now the thing that you need to be careful with this problem, or problems like this, is when you cancel, you're left with 1 in the numerator and in the denominator. These don't just go away as 0. Okay, and especially since you see that this is the denominator, make sure you leave that as in the denominator. You can't just say this is n plus 1 times n. Okay, and that's the final answer. Number 13, find the infinite sum of the geometric series. So we're given very little here. We're given the first term, and then we're also given some other terms, so we can find r. And notice these numbers are, the absolute value of these numbers are getting smaller each time, so that means that there is going to be an infinite sum. Otherwise, you're not going to be able to find the infinite sum. Like if it was 2, 4, 8, 16, and you couldn't find the infinite sum of that because it will just keep on growing. So since it's an infinite sum, we're going to use this formula right here. And we have the first term, we need to find r. So r is just going to be 2 divided by negative 3, which is negative 2/3. And if we multiply 2 by negative 2/3, we get negative 4/3. And this looks like it does work every time, so we can continue. What do we have to do when we're using the infinite sum? Always check to see if this is less than 1. Absolute value of this is less than 1. And it is, so that we can continue. Okay, so the infinite sum will be the first term times 1 over 1 minus the r, which is negative 2/3. 1 minus a negative 2/3 is going to be 5/3. And then negative 3, or actually 1 divided by 5/3 is actually 1 times 3/5 because we take the reciprocal multiply, and negative 3 times 3 is negative 9/5. One more. Write as a fraction. Okay, so you have 0.03 and then only the 4 is repeating. So we're going to separate this into 2 separate decimals or 2 separate numbers. It'll be 0.03 and 0.00 repeating 4. So 0.03 as a fraction is 3/100 plus 4 over 9 gives me a repeating 4. And because there's 2 places before the 4, we have to put 2 zeros. Okay, the 4 repeats 4 over 9, and we have 2 zeros. I'm going to put 2 zeros after the 9, so we have 900. So kind of have to push this 4 over a little bit on the decimal. So in order to add these two fractions, we're going to get a common denominator of 900. So we multiply the numerator and denominator by 9, and we get 27 over 900 plus 4 over 900, which is 31 over 900. This is the final answer, but make sure to check if this can be reduced. 31 is a prime number, so that means nothing can be reduced here when we're finished. Okay, that's your whole practice test. And as I promised, the last slide is all the formulas in one place. You have the arithmetic to find the explicit formula for any particular term in the sequence. We have the sum of the series for arithmetic series. We have the recursive formula for finding the next term for arithmetic. As the next term is the previous one plus the common difference. For finite geometric sequence, this is a formula for any particular term or the explicit formula. And for the sum of the series, this is a formula for that. And this is a recursive for a geometric sequence. And for finite geometric series, these two will be the same, and the only thing is this top part will go to 1, because if we take an infinite number, n to the infinite number, this will become very big, and it will just go away because r is very small. R is less than 1, so this will kind of shrink to nothing. So this part right here will just shrink to nothing. 1 minus nothing is just 1, and that's how you get the infinite sum. All right. Make sure you study the test and be ready for questions tomorrow. Or tomorrow meaning Monday.